Hi everyone, and welcome to the brief Chapter 9 Vocab video. So this chapter is all about acids and bases. So an acid, by definition, and there are different definitions of acids. The Arrhenius definition of an acid is something that produces an H+, a hydrogen ion, or also called a proton, in water. The Bronsted-Lowry definition of an acid is anything that is a proton donor. So there's two different definitions of acid to know. Acidic is any solution that has a high concentration of hydrogen ions, H+, or hydronium ions, H3O+. The autoionization of water is the process by which water molecules can ionize. So you can take two water molecules, they come into contact, and one steals a hydrogen from the other, and what you have as a result is a hydroxide and a hydronium ion. OH- is hydroxide, that's one of your words, and H3O+ is hydronium. A base is the opposite of an acid. A base is, the Arrhenius definition of a base is that it is anything that produces OH- or hydroxide in water. And according to Bronsted-Lowry definition, a base is anything that acts as a proton acceptor, so it accepts a proton. Something that is basic is the description of a solution that has a high concentration of hydroxide, OH- ions. A buffer is a type of solution that contains roughly equal parts of a weak acid and its conjugate base, or a weak base and its conjugate acid, and it resists change in pH. Chemical equilibrium is represented by a two-way arrow in an equilibrium equation, and the definition of chemical equilibrium is it is when the rates, the forward rate and the reverse rate, are equal in a reversible chemical reaction. Conjugate acid and conjugate bases occur in acid-base reactions, where in the Bronsted-Lowry context, where the acid donates a proton, and then on the flip side it becomes the conjugate base, and the base, after it accepts a proton, on the flip side becomes the conjugate acid. So a conjugate acid is the base plus a hydrogen, and the conjugate base is the acid minus its hydrogen. The equilibrium constant, K, is a ratio of the concentration of the products to the concentration of the reactants at equilibrium. So it's concentration of products over concentration of the reactants. The hydronium ion, like I said, H3O+, hydroxide ion, OH-. Le Chatelier's principle says that if an equilibrium is disturbed, it will shift in order to get back to equilibrium. And there are many ways to do this. You can add or subtract materials, you can change the temperature. Acidosis and alkalosis is a condition of the blood where it becomes either acidic or basic. Acidic, acidosis, and acidic solutions, you could add this, acidic solutions have a low pH. Basic solutions, or alkaline or alkalosis, involves a high pH. Neutral is pH of 7, and it has an equal amount of hydronium and hydroxide. Neutralization is what we call reactions where we mix an acid and a base. Acids and bases are sort of opposite, and they neutralize each other. When you mix a strong acid and a strong base, two really harmful substances, you end up with a salt and water, which are usually harmless substances. Where was I? pH. pH is a measure of the concentration of hydronium ions in a solution, or the measure of acidity of a solution. Salt is a chemistry term for any ionic compound. We use table salt, which is sodium chloride, on a regular basis, so we think of that as the salt, but Not all salt, even in our everyday life, is made of sodium chloride. Salt for the roads is made up of usually calcium chloride or magnesium chloride. Don't eat that. Epsom salt is magnesium sulfate. So a salt is just any ionic compound. A strong acid or a strong base, these are strong electrolytes. They are acids or bases that completely dissociate, and so they have a very strong effect on the pH of a solution. A weak acid or a weak base, like a weak electrolyte, only partially dissociates. And that's the end of this video.